Hello there, physics students. This is Mr. Neutzel, and I am going to give you the introduction to the CVPM unit. You might think, what does CVPM unit stand for? That stands for constant velocity particle model. Okay, the constant velocity particle model is what we're going to be spending the first couple weeks going through, trying to understand how things move along. We're going to simplify motion. For one, we're going to call it the particle model because it's going to be simplified down to just a single dot that's going along, moving along. The other thing is it's going to have the same velocity the entire time it moves that way. Okay, we're going to be working on putting up a little data table here, and you're going to go through and add in these ideas. So basically at the start of every unit we'll have something like this where it talks about the physical quantities that we're working with, the description of that physical quantity, and the symbol and the units. Our very first idea is defining what distance is. We're going to call it the separation between two different points. The symbol will be d, and the units for that is meters. Okay, so distance. The first unit we start off with trying to just basically describe really basic concepts. Next up is position. We're going to call position is the location of something in reference to a known origin. The symbol for position is x. It is also going to be abbreviated with or its unit is also a meter. Third, we have displacement. Displacement is called a change in position. For us to get a little understanding of how these three things work in relation to each other, I'm going to go ahead and draw in a little number line here and give us an origin and some positions on here. So let's say this is my origin, which means this would be 1, 2, and 3, or I could change them by whatever I wanted to count by. -1, -2, -3. Okay, so if I put a dot over here, and I'm going to put in a blue dot. Let's say we put a dot right there. We have a nice little blue dot sitting there. We could say that its position equals 2. That's its initial position. So I call that x sub I. That's the initial position. Let's say our little dot decided to move. Our little particle moves over to, let's say it moves over here. So later on in time, it's now located at x final equals -1. So if we were to count the distance it traveled, the distance would be 2 minus -1, which would be 3. You could even count, you could hop 1, 2, 3 spaces over. Our distance traveled would be 3 of whatever our units are. I probably should say these are meters. Okay, so the distance traveled would be 3. My displacement, though, is my final position minus my initial position, xf minus xi. So that would be -1 minus 2, which is -3. So displacement for this object has a displacement of -3. However, its distance is +3. Distance is never a negative number. Displacement can be a negative number because displacement is the change in your position, and your position has to do with a known origin. Okay, so that's just a little bit of a introduction to some of those terms. They actually turn out to be pretty important, but let's keep going on. Next up we have time. If you've ever tried to confuse yourself trying to find time without reading that, we're going to say time is a difference between two clock readings. You get out your phone, you get out your stopwatch, and you hit start and stop, and the time would be the difference between those two readings on your phone or on a clock. It's going to be measured in seconds, and we abbreviate that as an S. The unit or the symbol for time is T. Next up we have speed. Speed is going to be defined as the distance traveled over a period of time. And we have a formula, speed equals distance divided by time. This is our second formula. The first formula was change in position, final position minus initial position. And this right here is a delta x. Delta means change. So anytime you see a change in something, you could plug in a little triangle. It's the Greek symbol delta. And then the last major idea in here, last major physical quantity we're going to be looking at is velocity. Velocity is your displacement over a period of time, also measured in meters per second. So the formula V equals change in x divided by t. Speed can never have a negative value because it's always distance, and distance can't have a negative value. Velocity, however, can have a negative value because displacement can have a negative value. So if we go back to our little example we were looking at, where the object moved from 2 all the way back to -1, that would have happened, if we said that happened over 6 seconds, we could say our velocity would be -3 divided by 6. It would have a negative 0.5 meters per second velocity. So these are just some of the basic introduction ideas in the constant velocity particle model. You're going to need this as we start talking about things. I do want to say that physics is kind of like a foreign language. We use a lot of a foreign language that sounds like English. We use a lot of words that you're used to in English, but in physics we define them very, very specifically. So keep that in mind as we go through. How you define things, it matters how you go about plugging them into equations using math. So hopefully this makes a little bit of sense. You should watch this video before class next week, and I will see you guys later.